Welcome to this lecture. In the last lecture, we had started to discuss about combinatorial testing. We will discuss these testing techniques today in further detail. We will first revisit what we discussed in the last lecture, and then we will discuss further. The word combinatorial, if you look in the dictionary, it means relating to or involving combinations. The idea here is that in testing a software, there are multiple inputs and conditions, and in the previous lectures we had seen how to design black box test cases based on the input values, looked at equivalence class, boundary values and so on. But then when there are multiple inputs, we need to design test cases based on various possible combinations among these input, and also there can be global variables and so on, and therefore, the combinations must be considered. And of course, the combinations can become too many, and then it becomes difficult to test, and we will today see how to reduce the number of combinatorial test cases. First, we will discuss the combinatorial test case design, and later we will see how to reduce the number of test cases that are designed. The behavior of a program is affected by many factors. For example, the specific parameters we give as input, and there can be data stored as global variables. For example, arrays in a library example may be books, members. These are large arrays, and their state changes depending on whether a book is issued, returned and so on. And there can be state variables which define the state of the software. We had seen that in the previous lecture that for every input variable, using the black box testing technique of equivalence class, boundary values and so on, we can design test cases. And then we have to consider various possible ways of combining these inputs. But the problem is that often the input may be too many. There may be many parameters, environmental variable, state variable and so on, and the number of test cases required for all possible combination may become trillions, and the test should become extremely large, and then we will see how to address this problem and reduce the number of test cases. But first, let us see the basic idea behind combinatorial generation of test cases, and then we will see how to reduce the number of tests. Let us look at one specific test situation. This is a user interface for a word processing software. You might have used similar software where we can define the font characteristics, and see here we have many things to choose here. For example, whether the entire font is a superscript, subscript, small cap, all cap, then the font color, then the specific font type, and whether it is a regular, italic and so on, and the size of the font and so on. This kind of interface is very common in user interfaces, but then if we want to test based on all possible combinations of the input, then it may become too many. For example, we would like to check whether it works well in superscript and when text font is something and text color is something, and whether it works as subscript when for the same font color, size and so on. This kind of situation is also there in controller applications, where the controller behavior is defined by many factors, for example, temperature, pressure, user input and other factors. With this motivation, we will discuss three main types of combinatorial testing. One is called as the decision table based testing, cause effect graphing and pairwise testing. The pairwise testing actually reduces the number of test cases which may be obtained through a decision table or cause effect graphing. Let us revisit the decision table based testing. In decision table, the upper rows of the table are the conditions which are basically the inputs, and the lower rows are the actions, and these are the output. And this table allows us to consider various possible combinations of the conditions. If there are 4 conditions here and all conditions are Boolean, then if we consider all possible combinations, we will get 16 rows here. But the conditions may not be Boolean, it can be, let us say, an integer taking value 1 to 10 for a choice and so on. So, you can know, once we list down the conditions and actions, we know that what are the possible values of the input here, and we can define the rules based on the specific values of the inputs, distinct values of the input, and then identify which of the actions take place for that specific combination of conditions. And each of the column here becomes a test case, and this is called as a rule, because this is a specific combination of conditions, and each of these become a test case. Just to get a feel of it, let us try to do the decision table for this expression that is given here. Here, let us assume that C 1, C 2, C 3 are Boolean expressions, and if this is true, then A 1 is the action. But if the outcome of this specific combination is false, then there is no action. But this is the simplest, as I was saying. We might have much more complex, where we might have several actions possible depending on specific outcome of the expression. Just to explain the concept, how to draw the decision table for an expression like this, we need to write the conditions here C 1, C 2 and C 3. These are the upper rows of the decision table, and the lower row are the actions. We will just put a line here and we will write conditions or inputs, and we will write here the action, and we will consider various combinations of conditions of the truth value of these conditions, and each of these we will call as a rule or a test case. Let us say C 1 is true, C 2 is true, C 3 is true, and therefore, the action A 1 is yes, it will be taken. If C 1 is true, C 2 is true and C 3 is false, then still it is yes. But if C 1 is true, C 2 is false and C 3 is false, then it will be no, and so on. So, this is the simple way to construct a decision table. Given a simple expression, we should be able to write the decision table for that, and these become the test cases in a decision table based testing. So, the idea here is that we write the conditions in the top rows, actions in the bottom rows, and consider various combinations of conditions, and each of these become a test case and we call them as rules. Let us take a very simple example. Let us assume that we are trying to design the decision table based testing for a function which is check triangle. Check triangle, the name of the function, and takes 3 integers a, b, c as its input, and the function will display that the specific triangle is a scalene, isosceles, equilateral, not a triangle, and so on. Now, here the conditions based on which the action are taken can write here the top rows. C 1 is that it forms a triangle, C 2 a equal to b, C 3 is a equal to c, C 4 is b equal to c. So, if it is a triangle, if it is a equal to b, b equal to c equal to a, then it is a 4 is a equilateral triangle. If it is not a triangle, then it will display not a triangle, that is a 1, and so on. We can easily develop this table, but the problem is that here we have written here the condition 1 is ABC form a triangle, but that is not a very practical condition to check. We will see that we can refine the table, but once we have drawn the decision table, we can design the test cases which are specific combinations of the conditions, and the corresponding actions are the output to be checked. And if C 1 is that A B C is not a triangle is true, then the display will be not a triangle irrespective of the condition C 2, C 3, C 4. We can do that, write the specific value which will satisfy condition 1, which is 4, 1, 2, and then we say the expected output is not a triangle. Similarly, if it is a triangle and also A equal to B, B equal to C, C equal to A, then we write some specific values which satisfies that condition, and the expected output is equilateral. And each of these is a test case. We give the test case number here, test case ID, and that is how we design the equivalent the decision table based test cases. This is a more complete decision table for the example we discussed, because in the top row we have replaced whether it forms a triangle or not with specific conditions which are easier to check. A is less than B plus C, B is less than A plus C, C equal to less than A plus B, and if all of this is true, then it forms a triangle. As long as it is false, then the output is not a triangle. But if all the three conditions here C1, C2, C3 is true, then it forms a triangle, and therefore, we check the other condition C4, C5, C6, and based on that we write whether it is a scalene, isosceles, equilateral, or it is impossible. Impossible is that it is not any integer values and so on. And once we have developed the table, we can write specific values for the input, and we write the expected output, and all of these form a test case. Let us take one more example, which is the printer troubleshooting example. Here, depending on some specific condition, the program recommends some action to take. For example, if the printer does not print, red light is flashing and printer is unrecognized, it recommends check printer cable, ensure printer software is installed, and check or replace ink. If it is printer is not printing and red light is flashing only, there is no printer unrecognized message, and then need to check and replace ink and check for paper jam. Similarly, if there is printer does not print and printer is unrecognized, then we need to check the power cable for the printer, and we need to check the printer cable and ensure that the printer software is installed, and so on. We develop the table, and each of the columns here become a test case. Let us develop the test case, decision table test case for a specific situation. If a flight is more than half full and ticket cost is more than 3,000, free meals are served. Unless it is a domestic flight, in domestic flight meals are served, but these are not free. But if the flight is not half full, is less than half full, and ticket cost is less than 3,000 or ticket cost is less than 3,000, then no meals are served. To develop the decision table for this, we need to identify the conditions. The specific conditions here is that whether the flight is more than half full, we will write that as condition 1. Ticket cost is more than 3,000, we will write that as condition 2. The actions is whether free meal is served or meal is served, and whether it is a domestic flight. So, this is the third condition here. The flight is more than half full, ticket cost is more than 3,000, and it is a domestic flight. We can identify that these are the conditions, and the actions are that whether meal is served and whether it is free. So, we can write here C1, C2, C3 and action 1, action 2. Action 1 is whether meal is served and action 2 is whether it is free. And we will check whether C1 is that flight is more than half full, ticket cost is more than 3,000 and it is a domestic flight, then meal is served. A1, let me just write here, meal is served, and A2 is that it is free meal. So, we will write here yes and A2 is no. Similarly, if it is more than half full and it is ticket cost is more than 3000, but it is not a domestic flight, then meal is served and also it is free, and so on. We can find all possible combinations of the conditions, and each of the columns here will become a test case. So, just drawn here for your reference that these are the three conditions, and then the specific actions. We write all possible combinations of the conditions. If there are 3 here and each is a binary, then we will have 2 to the power 3 8, that is the number of columns here. It will give all possible combinations of the conditions of these 3 input Boolean variables. In this we have filled up the action part, and each of these become a test case, and then the corresponding actions are checked when the test case is executed. But then even using a decision table, we can optimize the number of test cases, we can reduce little bit. For example, this is the decision table that we developed, but then we can see here that the action part is the same here. The action part is the same here, there is no action for these two test cases or rules, but then the specific input values are same for both of these conditions, and this is just no and yes, and therefore, we can combine this into a single rule and we will write do not care here. It is possible to combine these two because the action part is the same, and irrespective of the domestic flight, nothing is done if it is less than 3000 and less than half full. Similarly, we can combine these two. The action part is the same and then they differ with respect to this. So, this becomes a do not care. But what about this? This we cannot combine with any other, because the action we do not have. Okay, we have this here, the same action here, but then okay, we can combine either this with this, that these two are having same action, or we can combine this rule with this rule. So, they have the same action part and then they differ with respect to only more than 3000. So, you can combine this into single rule, and then we cannot combine this further with this, because we already do not care here. So, I have drawn that, reduced the number of test cases, and have written here do not care. So, the number of test cases required here is 4. Now, in the decision table based testing, we must ensure that all possible combinations of the decisions of the conditions are taken care, and also we must ensure that the rules are consistent. That is, it should not be the case that for the same combination of condition we are writing two different actions. That is inconsistency basically. If we write let us say 3 conditions yes, yes and yes, and we write that action A1 is yes and A2 is no, and for another rule we write same combination of condition and the actions are different. It cannot happen because this is inconsistency. We must take care that the table is consistent and all possible combinations of conditions are present, and that will give us our decision based test cases. The decision based test cases, decision table based test cases are relevant for many problems. If we look at the code and see that there is lot of decision, not code, if we look at the description of the program and see that the specification involves lot of decision making. The output is a logical relation among input variables. The results depend on calculation involving subsets of input, or there are cause and effect relationship between input and output. These are the cases where we have to design the decision table based test cases. But the only problem with the decision table based test cases is that as the number of input conditions become large, the table size grows exponentially. If we have 3 conditions, Boolean conditions, we need 8 test cases. If we have 4, we need 16, 5, 32, and so on. If we have 10, then 1000. So, becomes difficult to develop the table, and the number of test cases grows very rapidly. It becomes difficult to optimize manually, reduce the number of test cases and so on. Also, the decision table based test cases, even though it is very simple if we understand the problem very well, but then if we do not understand the problem very well, it becomes difficult to develop the decision table, and we will look at another technique which is cause effect graphing, which gives us a graphical way to represent the input conditions, output conditions, and from there can develop the decision table. We are already at the end of this lecture. We will stop here, continue in the next lecture. Thank you.